Happy fun science time.
Hello, I'm Torky, and welcome to Happy Fun Science Time.
Hi, I'm Zooky. Today's episode is our first episode with a theme song. What do you think about this one?
Nope.
How about this one?
Nope.
Oh well, we will come up with a theme song for next episode. Today's episode is on deep learning.
Deep learning is a technique for programming artificial intelligence systems. Deep learning uses a hierarchical learning system, which is similar to the way the brain stores and processes information.
There's a lot of funding going into understanding and modeling a human brain and a computer system. One of the largest in Europe is a Human Brain Project.
The Human Brain Project is a collaborative project which encompasses dozens of research groups from many countries. Yay!
Wow, so science! Just look at all those collaboration partners on their website.
That's just one of the projects trying to emulate how the human brain works in computers. Deep learning AI works by taking an input from the environment, which can be a picture or a sound for example, and analyzing the input for specific patterns. Each pattern is activated as a node. Higher level nodes are activated by the combined activation of lower level nodes. In the example of a picture of a dog, a group of pixels may be recognized by the software as a specific feature like an edge. This will activate a lower level node corresponding to the type of edge that was detected. If a number of these edge nodes are activated in a certain order, it will trigger the activation of a higher level node in the hierarchy, such as a tail, a paw, or a head. If these higher level nodes are activated in a certain order, a single node representing the complete concept will be activated. A dog in this case.
It looks more like a rat to me.
Publicly funded research projects are not the only groups interested in this technology. Google recently showed their deep learning AI thousands of YouTube videos. The AI was able to create concepts of a human face, as well as the face of a cat. For the example of Google's deep learning algorithm, pixels are fed into the 16,000 CPU processor, where the algorithm works out various hierarchies of nodes which contain edges and shapes, until it arrives at a human face, or the face of a cat, using the same hierarchical method in the example describing the dog.
It's a rat. Also, as you can see from the picture, a cat node is a higher level node than the human node because cats are the best.
I think that the red panda node would be the highest of all.
What is a red panda? I don't know about that.
Computer intelligence began before deep learning. One notable example of a computer intelligence performing a complex task better than any human is when Deep Blue beat the chess grandmaster Garry Kasparov in 1996 and 1997. However, chess is a very structured game with a very structured set of rules. Chess can therefore be solved for every situation using a brute force method. This is not the same as how people learn, but it was a good step for AI.
There's a Kasparov's rage quitting from a match against Deep Blue.
We instead want computers to be able to solve novel tasks and learn complex situations on its own, much the way a human does. For example, suppose a question is posed to a computer, such as, how would Arnold Schwarzenegger react to this robot? The solution to this problem is complex and requires the formulation of an Arnold model in order to predict how he would behave. Defining the purpose of the question also requires context cues,
Such as knowledge of movies for trivia.
or an understanding of what is involved in the images, as well as an understanding of Arnold's psychology. For these reasons, although deep learning models began in the 1980s, they were not implemented at that time due to limitations in computational power and access to big data. Therefore, during this time, more traditional brute force methods were favorable. However, as Moore's law provided an exponentially increasing amount of computational power, and access to the internet allowed for big data analysis, deep learning models began to outperform traditional models.
We still have a long way to go through before deep learning can match the human brain.
The next notable computer system to outperform humans at complex tasks was when Watson beat the top Jeopardy players.
date, in this city, U.S. flag bearer Ralph Rose caused controversy by not lowering the flag when passing the king. Watson?
What is London?
Correct.
Name the decade.
Watson does contain elements of deep learning-based software, but also has a long way to go.
First modern crossword puzzle is published and Oreo cookies are introduced. Ken?
What are the 20s?
No. Watson?
What is 1920s?
No, Ken said that.
Watson is currently not playing Jeopardy, but instead diagnosing diseases and is already diagnosing people much better than doctors.
Today, you can find deep learning software in many things, from Google Plus to Siri and iPhones.
Deep learning software is even learning to play games!
Yay!
Yay!
Here's a clip of deep learning software learning how to play Breakout better than any human.
Around 100 games. So you can see it's not very good, but you can see it's sort of understanding slowly. You can see it's kind of understanding what it's supposed to be doing. It's trying to move towards the ball. This is after an hour of training, so about 200 games. So now you can see it's quantitatively better. It's getting the ball back around 30-40% of the time. It's still not perfect, but it's getting measurably better. Now after 2 hours, or 300 games, it's better than any human can play this game. So it never misses the ball, even when the ball comes back at very fast vertical angles. So then we thought, okay, that's pretty good, but let's just leave it training for another 2 hours, see what happens. And then this amazing thing happened. It sort of worked out. The optimal strategy would dig a tunnel to the back, and then send the ball round the back.
Deep learning also has been used to create novel concepts, such as this design for a walker for space probes, which can navigate a wide range of terrains. This is completely novel design and was thought up by a deep learning software.
Image recognition currently is a main focus of deep learning.
We found this demo you can try online, where a deep learning software will tell you what is in a picture. So the website is called deeplearning.net, and it contains links to a number of demos. In this particular demo, you can upload pictures. The software will then analyze the picture and try to tell you what is going on.
That sounds interesting. Let's start with an easy one. How about one of a red panda?
Okay, so here's our picture of the red panda, and we're uploading it to the website. Let's see what it has to say. For the tags, it has a bear, a wolverine, bobcat, bears, and savannah.
Uh-oh, spaghetti here. I guess the AI doesn't know what is a red panda neither.
And the nearest sentence describing it is, a polar bear eats a carrot on a snowy field. So it got this one completely wrong. I think it should at least know what a red panda is, if it's gonna be useful. Okay, let's try another one.
Okay.
So now we're going to try and trick the AI deliberately.
This is a picture of my cousin dressed as a spider for Halloween.
And we're uploading the image. And as you can see, the tags are duvet, kitten, furry, pillow, and fuzzy. So they got the kitten right, anyway. The nearest neighbor sentence is a little girl laying in bed holding a book next to a cat.
I kind of expect that since this AI even didn't recognize a red panda. Let's do one more. I'm currently bothered by a question that many people have wondered in a Japanese animation about a character named Elizabeth. Let's see if the AI can answer it for us.
桂小太郎上位志士江戸の町からアマントと呼ばれる宇宙人を排除しようとしている活動家エリザベスつうか何これ
So now we're uploading the third one, the third picture, to figure out what this creature is. And The nearest neighbor sentence is, a display of scissors is shown on a white background.
Oh well, thanks AI, we finally know what Elizabeth is.
Some of these other ones are quite good with this one. A pair of scissors and a glass of wine.
This question might be still too hard for an AI. Let's hope that AI can give us a more accurate answer to this question in the near future.
In the near future, deep learning software will be everywhere, from augmented reality apps and devices like Google Glasses to self-driving cars to medicine. Recently, a panel of scientists such as Stephen Hawking and entrepreneur Elon Musk warned of the need to carefully approach the development of AI so that it doesn't take over the world, like in the movie Terminator or The Matrix, and in civilization as we know it. What do you think, Zooky? Will AI take over everything?
I totally agree with Stephen Hawking and Elon Musk that robots will take over the world once they are well developed. They are able to think and learn much faster than human beings.
I think it is a danger, but I also think that since scientists are actively working to prevent it, that we will be okay.
I don't think we'll be able to stop them once they develop their own ideas and concepts.
Well, that's our show for today. Thanks for watching, everyone.
Please like, comment, and subscribe, and let us know if you think the robots will take over!
And be sure to watch for our upcoming new episodes. Bye, everyone!